In this video, we're going to look at how you can solve a rational inequality using a procedure very similar to what I used when we solved a nonlinear inequality. I'll put a link to that video in the description, so if you want to look at that first, you can do so. Okay, but the procedure is very similar. So here's the first problem we're going to look at for this video. We want to solve x plus 4 over x minus 2. It's a rational expression less than or equal to 1. So just like the other procedure I just mentioned, one side should be 0. Doesn't really matter. Usually it's going to be the right side. So we can do that by subtracting 1 from both sides. Okay, if we do subtract 1 from the right side, we get 0. Subtract 1 from the left side, we get this expression here. And then you always want to make the, once you made one side 0, you want to make the left side into one rational expression. So in some cases, you'll have to combine two expressions. Find the lowest common denominator and proceed. So in this case, this one here, you make this into minus 1 over 1. And then the common denominator you can see is x minus 2. So we're going to multiply the second expression here, in this case minus 1 over 1, by x minus 2 and x minus 2. And we get this expression right here. Now we have the same denominators. Now we just add up the numerator. So x plus 4, and then you have a minus 1 here, so we multiply by minus 1. Minus 1 times x, add it to x, cancels to 0. Minus 1 times minus 2 is a plus 2, and a 4 gives me 6. So that then gives me this inequality. 6 over x minus 2 is less than or equal to 0. So now, procedure then is once you've made the left side into a single rational expression, is find the number or numbers that make either the numerator 0 or the denominator 0. Okay? Now, since there's no x in the numerator, there's no way the 6 can be 0. But for the denominator, x minus 2 is 0 when x equals to 2. So what we do then is on a number line, we plot the number 2. So there's your number line. In this case, we're only going to have two intervals because there's only one critical number, as we call them. So we plot the 2. And then basically this divides the number line into two regions. Okay, on the right this is plus infinity. On the left, far left over here, that's minus infinity. So what we do then is we look for the sign. What is the sign of this expression here? 6 over x minus 2 for numbers larger than 2, for numbers less than 2. So all you can do is pick a number larger than 2. Doesn't matter which one you pick. You can pick 2.1, 2.5, you can pick 3, you can pick 1,000, because that's way out here, okay? But we stay close to the critical number, in this case 2, so we pick 3, put a 3 there. 3 minus 2, let's see, all you want is the sign. 3 minus 2 is a positive 1. Positive 1 into 6 is a positive 6. We just care about the sign, so we just put a plus right here. Then pick a number less than 2. That could be 1. It could be 0. Okay. Let's pick a 0. 0 minus 2 is a negative. And a negative into a positive 6 is a negative. So this is negative. Now all you have to do is read the answer from the number line. What do we want? We want less than or equal. But the main thing here is you want less than 0. That means a negative. So you simply look at the interval. Or intervals, because there could be more than one interval with that sign, as you'll see in the next problem. So right in here, less than 2, we have a negative, so that's what we want. The solution then is all numbers that are less than 2. So you go back over here to negative infinity, all the way to 2. And we write the answer usually in interval notation. At least that's the way I requested it. Your instructor might request a different solution. Okay, for problem 2, we have 1 over x minus 2 is less than 2 over 3x minus 9. So again, we want one side 0, so I'm going to bring this 2 over 3x minus 9 to the other side. And all I did here is I added the opposite of this expression, 2 over 3x minus 9. to both sides. It got us this. And at the same time, here I factored out a 3 just to make it easier. Factored out the 3. Here's what we have. Now all you do is combine this into one. We have one side 0, in this case the right side. I want to combine this into one expression. So our LCD is, this has an x minus 2, this has x minus 3, and a 3. So we want to have the same denominator for both. So this one has x minus 2, doesn't have the x minus 3, so we got to multiply here by x minus 3, and the numerator by x minus 3. Doesn't have a 3 also, so we're going to multiply by 3 and 3. Now this one over here is just missing the x minus 2 then. So we multiply by x minus 2, and that'll give us this. Okay, so notice I have the same factors in the bottom for the first one, and also over here for the second one. They could be in a different order, but you have the factors x minus 2, x minus 3 in both. And of course you have the 3. This expression here is the same as what I have over here. I just found the common denominator and added up and rewrote it. That is, now we're going to add it up. So here then, since we have the same denominator, we're going to multiply this by 3x here. So let me just put it up here on the top. So this will be 3x. And 3 times minus 3 is a minus 9. For this one, multiply here. They have a minus here, so this is minus 2 times that. So minus 2 times x is minus 2x. And then a minus 2 times a minus 2 is a plus 4. Okay, so 3x minus 2x is x. Minus 9 and a plus 4 is a minus 5. Okay. So this is what it reduces to. Combining the numerators, I get x minus 5 over 3 times x minus 2, x minus 5. And you see, that's why you want to leave it in factored format, because we're looking for the number or numbers that make either the numerator 0 or the denominator 0. So you can see the denominator is 0 when x is 2, x minus 2 is 0 when x is 2. Okay, and this factor here is 0 when x is 3, so we're looking for the numbers that make either the numerator or the denominator 0. X minus 5 in the numerator will be 0 when x is 5. So the numbers we want on the number line are 2, 3, and 5. So there's my number line, and we're going to plot the 2 in order of size, from smallest to largest, left to right, and the 3, and then the 5. Okay, and again, infinity is over here on the far right, negative infinity far left over here, and all we want is the sign of this expression right here when we pick numbers greater than 5. Okay, so you can see if I pick a number larger than 5, say 6, this 6 minus 2 will be positive, 6 minus 3 would be positive, 6 minus 5 will be positive. So we got all positives in the numerator, positives in the denominator, so this will be a plus. Now between 3 and 4, or 3 and 5 I should say, pick any number. Well, the most convenient one would be 4. So let's put a 4. 4 minus 5 is a negative. So the numerator is negative. 4 minus 2 is a positive. Okay? And 4 minus 3 is a positive. So two positives multiplied in the denominator are positive. The numerator is negative. Positive into a negative is a negative. I'll put a negative right there. Okay, between 2 and 3, again, we want the sign of this expression here. We'll pick 2.5. 2.5 minus 2 is a positive number. 2.5 minus 3 is a negative number. 2.5 minus 5 is a negative, so the two negatives cancel out, and this is positive, so this comes out positive. Okay, now we pick a number less than 2, any number you want. Let's pick a 0. Okay, so 0 minus 5 is a negative. 0 minus 2 is a negative. 0 minus 3 is a negative. 3, of course, doesn't matter because it's positive. So here, these two are negative here. Negative times a negative is a positive, but the numerator is a negative. Positive into a negative is a negative. So what do we want in this one? We want less than 0 or negative here. Look at the last one right here. So you simply look at the intervals on this number line that are less than 0 or negative. So that would be this one right here, this one right here. So it's everything less than 2, together with everything between 3 and 5. So my solution set, I can just say the solution set is x less than 2 or union x is greater than 3 and less than 5. And this is the way you would write it in interval notation. Okay. The only way you would have a bracket in one of these numbers is possibly if you had a less than or equal. If you had the equals also. But keep in mind that when you have a fraction, you cannot have a number as a solution that makes the denominator 0 because it's undefined. Okay, so the only one that would have a bracket in this type of problem is if you have the less than or greater than or equal, and that number makes the numerator 0, not the denominator, because the division by 0 is undefined. So in this case, this is your solution. Again, there's a link in the description to the other video that uses a similar procedure as we use here. Thanks for watching. We'll see you next time.